Hello. Today I would like to further explain the landscape ecology measurements I developed at the site level. First one is richness. Richness is calculate the number of landscapes elements per area. For example, like in this case, like this, if this was the whole area, if there is all of the area are one type of landscapes, then there will be richness of 0. And if the and there's two kind of landscapes, then the richness is not gonna be 0. So richness is just a way to compare how many different types of landscapes you have in certain area. Okay, like here, 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 and here. Okay, and and this one is definitely have more richness than this one, because the area is the same, but here we have 4 different types. Here we only have 2. Okay, so that's kind of the idea. Next is what we call diversity. What this do is it does not only compare the number of the landscapes patches, but also the size. Okay, they require the category are different, the patches are different, but also with equable area, equable size. Here is the example. Okay, like in this area they got like 1, 2, 3, 4 different landscapes patches, and here they also get 4. So all of them have 4 different, in terms, if you do like the total area is the same, if you calculate the richness, they're gonna be the same, but the diversity is different, because in this area most of them are just this pink field. Okay, and all this and these 3 are really, really small. So but this area, the size of these landscapes are pretty much the same. So we will see this one have bigger, like this one have bigger diversity compared to this one. Okay, because really this one, you can ignore these small patches, right? It's basically the whole area. Most of the area is just pink one. Okay, so this for diversity, and then edge density. This is for edge density. So for example, let's say if the richness is the same, right? They all have 4 different kind of landscapes, but the difference is the edge. Like here, this was the edge, and here, this was the edge. Okay, and what we'll do is the computer will calculate the total length of the edge. Okay, and in this case, because it's curved, and there should be more, like this one, like this one should have like a longer edge area than this one. Okay, even though the diversity, the richness is kind of the same, but since there is more area between 2 different patches, so we say they have higher edge density. Okay, heterogeneity. So what this one was is, for example, here is a grid, and in every grid, the same distance, you have different patches, different landscape types. Like in this case, it's really rich. Like every point, every grid has a different color. Every color have different size, have the same size. Okay, so and this one you see here, we only have 4 different colors, which is 4 different landscape types. but in terms of heterogeneity, these two are the same. The reason is heterogeneity just count the labor, which means the nearby landscape types. This area here to here are different, here to here different. Then that's okay. Like just labeling and here to here. Okay. So based on this point, the labor points, okay, labor area, have different landscape types, which means they're different. And then compared to this point, see here, it's different with all the labeling colors. Okay, so this in this cell is green, but all the labels are not green. In terms of heterogeneity, this still fits the requirements. Okay, so even though the richness on this one is smaller than that one, okay, than this one. All right. The other one I'm gonna look at is aggregation index. So basically what this was is this, I think this is a pretty good chart. It just show you how fragmented of one type of landscapes. Okay, like in all these charts, right? Like this one have aggregation index of 1, which means the highest. Okay. By the way, all these measurements, the higher the number are, which means the higher of the intensity are. Okay. Edge density, the higher number you have, higher edge density. Okay. And for aggregation index, so like this one, aggregation index is highest. It's because it's just really intact. It's just like a box, right? But here it's just so hard to break into there. Okay, so it's not fragmented. Like this one, see here, they have these kind of long stripes. It's really thin, so we feel it's really vulnerable. And this one is another extreme, which is super fragmented. Have really high fragmentation. Okay, but this one is another extreme. Okay, and shape index. This one is really simple, which means like regular shapes like this rectangle, triangle, right? Or so like this like regular geometries. Okay, which means the shape of one type of landscapes, if it's like this regular geometry shape, which means the shape index is gonna be really high. So this is gonna be 1 if it's pure square. Okay, but if it's like a really natural like this, the shape of it, then it definitely will have smaller shape index. Okay, because it's not like a geometry shape. All right, so this is another good measurements to figure out the style of a landscape. Is it like human-made, geometric, or is just this kind of a natural form? Okay, so I think this was this. If you have any question, let me know. Thanks.